Hi, I'm Brandon Graisley. I'm a high school math teacher. Let's talk about substituting in for variables and evaluating those expressions. So we often use formulas or expressions to help us solve problems in math. For example, you've probably seen some of these ones. This is A equals L times W, and that is the formula for the area of a rectangle. A is the variable that represents area, L represents the length of two parallel sides on the rectangle, and W the length of the other two sides, or the width we'll call it. And so this is an equation, or we'll call it often a formula, and it is made up of two expressions. This expression here is equal to this expression over here. And so to use this, typically we'll substitute in values for L and W. Say we measure a rectangle, measure the length, measure the width, fill in those values into the equation, evaluate this side, and that tells us that this side is equal to some number. So that's how we use these. We substitute in for variables, substitute in values, and then we evaluate the resulting expression to get a number. So you know quite a few of them actually. You've probably seen this one, another formula, another equation. This is the Pythagorean Theorem, which we use for right triangles, a relationship between the side lengths, A and B being the short sides, and C the length of the hypotenuse. The square of that hypotenuse is the sum of the squares of the other two sides. Maybe this one. That's for the perimeter of a rectangle. Again, L and W are length and width, and P stands for the perimeter. And how about this one here? There we've got pi r squared is equal to the area of a circle with radius r. Now this one pi here, that's actually not a variable. Even though it is a letter, it's a Greek letter. These other ones here are all variables. These can all be different numbers, but pi is actually a constant. And we typically use the number 3.14, at least for now, to represent that value. Although it is an infinitely non-terminating, it extends forever, list of decimal values that do not repeat. It's called an irrational number, and it's actually one that's called a transcendental number, which is a special kind of irrational number. So all of these letters, though, these are all variables that represent unknown values. So to use these, again, we fill those in, and I'm going to show you a few more that maybe you haven't seen before. Some of them you might have. Let me show you a few more that are really useful. N times n plus 1 divided by 2 is the sum of the first n natural numbers. If you add up the numbers from like 1 to 10, you would fill in the value 10 for n, and you would find out what adding up numbers from 1 to 10 will give you by using that little formula. Or how about this one? N times n plus 1 times 2n plus 1, and take that and divide it by 6. That's the sum of the squares of the first n numbers. So if you wanted to find out what 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared is, put in the number 5 into wherever it says n, evaluate this expression. That'll tell you what that sum will be. Okay, here's a few more. If I want to find the average of any two numbers, add them together and divide by 2. You've used that one a bunch. This one you probably haven't used yet. Here's an example of a quadratic, or a second degree polynomial. And if we graph this with a y equals, we end up with a nice pretty shape that looks like a curve, like a U shape. And this one you're going to spend a bunch of time on in grade 10 and 11. So that's called a second degree polynomial, or quadratic. This one here is used with quadratics. Oops, sorry, missed that. We've got a b, an a, and a c. These are three parameters that go with quadratics. They're coefficients. And we use this to tell some things about how this particular graph behaves. How about that one? That looks a lot like the area one that we had up here, and it is very similar. This is the surface area of a sphere with radius r. So that's pretty cool. Not something that's really obvious. And how about one more? 1/3 pi times r squared times h. So there r is radius and h is height, and this is for the volume of a cone. You got a cone that looks kind of like this, and if its height is h and the radius of its base is r, this little formula will tell you the volume. So we'll often write V equals, substitute stuff in on this side, evaluate, that number will tell you the volume of that cone. Okay, so let's use a couple of these to practice. So let's start with that rectangle one. Suppose I want to find the area of a rectangle. I'm going to use this formula. But until I know some things about it, I can't calculate the area. I need to know its length and its width. So let's suppose that I know that the length is, let's say 5, and the width is 7. Now I can use these values, substitute them into this equation in place of the variables, because L is no longer just an unknown. I know what it is, it's 5. So we're going to do that substitution. So I'm going to continue writing everything down the left here, the equal sign, and I'm going to, as usual, evaluate my expression by writing it all out and simplifying pieces as I go. Now when I substitute in, I'm going to do this with the color this time, but I always use brackets when I substitute in, and it'll save us some headaches later, and I'll show you why in the next example. So here are the two things that I have substituted. For L, I've put in the number 5, and for W, I've put in the number 7. And I now have A equals 5 times 7, which I can evaluate. I know that number is 35. So that's the substitution part, and then I've evaluated to get to this final number here. I don't always have an equation. Sometimes I just have this, an expression, which I evaluate and by simplifying. Okay, so this would be the area of a rectangle that has length 5 and width 7. It has an area of 35 square units. Okay, so once again, let's see why those brackets are really helpful. Let's look at this example. Let's evaluate that expression from above, the quadratic, I called it, this expression, when x is a specific value, -2. Now x can take almost, well in this case, any value, but I want to look at this specific situation when x is equal to 2. So when x equals 2, I'm going to substitute in the value -2. Now really important, put your brackets in. There's my -2 in brackets. That has to be squared. Then minus 5 times, well if I put the brackets, that times comes in automatically. That's super helpful. That means 5 times minus 5 times -2. Sweet. So if I have the brackets, immediately I get that almost automatically. Okay, so now I have an expression that I can evaluate because it is all in numbers now. So let's do that. -2 squared. That's 4. Positive 4, because that's -2 times -2. Here I have minus 5 times -2. Minus 5 times -2, that's positive 10 or plus 10. And then I'm left with that plus 6 at the end. Now I have 3 terms left. They're all just numbers. And I can add those up. 4 plus 10 is 14, plus another 6 is 20. So when x is -2, this expression is equal to the number 20. Now I want you to look really carefully right here at what happened when I used my brackets with this squaring bit. Over on the side here I'm going to write something that is incorrect. What if I had written this? -2 squared. Well, what that means, according to our order of operations, is that I should square the 2 and then subtract it from something, maybe subtracting it from 0 in this case. So if you write -2 squared, this negative bit does not get squared along with the 2. And that's incorrect, because here I want the value of x to be squared. The value of x includes that negative piece. So put your brackets in all the time, and you won't make a mistake losing a negative sign here. You could also make a mistake right here without that brackets. You might write -5, and then in place of x write -2. Well, that's -7. -5 minus 2. That's -7, not positive 10. That's wrong also. So those are both things you can avoid by including your brackets when you substitute values in. Okay, let's get one more in here before we wrap this up, and then I'll make another quick video with some more practice in it. So let's evaluate this same expression but using a different value, and we will possibly get a different answer. You don't always, but in this case we will. Let's evaluate that expression when x equals 1/2. So that's a fraction. It's a positive number. I can just replace x with 1/2 everywhere that it appears in this expression. So let's do that. I'll crack out my color here again, and I'm going to use my brackets. Again, this is a case with a fraction where it's really helpful to have those brackets so that you don't think I'm just squaring the 1. 1 squared divided by 2, it's really 1/2 all squared. And then I'm going to subtract 5 times x, which is 1/2, plus 6. And now 1/2 squared, that's 1/2 times 1/2. Let me do that over on the side because this causes some confusion sometimes. 1/2 times 1/2. Multiply across the top is 1. Multiply across the bottom is 1/4. I didn't write that mess over here. That's just some scratch work for me. Don't write this little line with the equal sign on this side. That's a mistake. So I'm replacing 1/2 squared by the number 1/4. Here I've got 5 times 1/2, and it's going to be negative. That's 5/2. If you want, write it as 5/1 times 1/2 and then multiply across. And then I've got my plus 6. Now let's get some common denominators so I can combine my three numbers. I've got quarters, halves, and these are wholes. Let's write them all out of 4. 1/4 minus 5/2 will become 10/4. And then to write 6 as some number of quarters, I had to multiply the bottom, which was 1, by 4. I'll multiply the top by 4 and get 24 on top. Okay, let's see. My positives, I've got 25, and I've got a negative 10. That's 25 minus 10 is positive 15/4. So when x is 1/2, this expression evaluates to 15/4. You can see that is a different number from 20 that we get when x is -2. So this expression, just like our area expression up here, takes on a bunch of different values depending on what you input into the expression. Okay, so that is substituting values into an expression and then evaluating it. Thanks.